Hi guys, welcome to Machine Learning in 5 minutes. My name is Chidi, and in this first project, we'll be building a machine learning prediction model using tabular dataset. And by the end of this video, you will be able to build your own machine learning model, which takes inputs like the number of bedrooms, the number of bathrooms, and the location of the house, and outputs an estimated price for the house. So let's get started. The first step is to upload your data set to your Google Drive inside my drive. As you can see, this is my drive, and I created a folder and I named the tutorial. If you open the folder, you find my data set named housing.csv. The step 2 is for you to open your workspace. As for me, I'm using Google Colab as my workspace. Now my data set is saved in my Google Drive, as you can see it here, and I'll have my workspace as Google Colab. I would like to link to that data set which is in my Google Drive. So what I do, I just use this line of code. If I run this, it will ask me to link to my Google Drive. As you can see, I've successfully linked to my Google Drive. Step 3, I just have to read my file. I want to read this CSV file inside Colab to see if it's fully connected. It will display. So use this line of code. Okay, I have an error here. CSV under parts, housing.csv. Okay, I've not run this, that's why. So now I run this code because I've saved this part into this variable name. So this was the variable name I called. If I didn't want to do this, I would have copied this line of code and pasted it directly into this bracket, and it will just go directly. You can see this is my CSV on my data set. Next thing, we fine-tune our data set. First thing, import the necessary library which we'll be using in this particular aspect of the code. Then we'll select relevant features. Okay, let's first specify our path to our code and save it inside this df. You see the save inside this df. This is our path to our data set, and it's saved inside df. So the next thing is to select the features, like which of these headings will be used as X and which will be used as Y. Y is the output, YS is what we'll be using to make our predictions. The column to make our prediction is S. YY is what we'll be predicting. In this case, we're predicting price, and we'll be using the bedrooms and the bathrooms to predict the price. So that's why I specify bedroom and bathroom. So after that, the next thing, we can choose to rescale or we can choose to skip that step. But let's go to rescale. You can see this is the code to rescale using a standard scaler. Remember, we have already imported this standard scaler, and then once after we rescaled, and last thing is for us to specify which of the data will be used for training and which one will be used for testing. So this is it. This is S train, S test, this line of code, and here we're using 20% of our data for testing, while the remaining 80% will be for training, because we test size at 0.2, meaning that this table contains 1, 2, 3, 4, 5 rows. 80% of these 5 rows, which is 8 times 5 is 40, which is 4 of these rows we use for training, while 1 of these rows will be used for testing. And now I have to train my model. And to train my model, since I'm using a tabular data set, I can use linear regression or I can use dense neural network. But for this project, I'll be using linear regression. So this linear regression method of training just have these 3 lines of code. This is where you import this linear regression. And now this linear regression is a constructor or an instantiation. So once I call this and I will save it inside this left side of the code, is model. I can call this model, I call it anything. It's like a variable that takes in that whatever has been called at the right hand side. Now I've called this model is equal to this, meaning that our model, which is variable, now have access to every method or functions of this linear regression. So now this I can now say model.anything because I've given it this value initially. So now I can call model.fit. This .fit is an object in this linear regression class, because linear regression is a class, because this is a library, it's a class already predefined. So this .fit is an object. This is an object in the linear regression class. So whenever I call this .fit, this model.fit helps me to train whatever argument is stored inside here. So now this will be training S train and Y train. And S train and Y train has already been defined in my train test split initially with this line of code. You see, I've specified S train and Y train, and I've already specified that the training data will be 80% of our data, which is 80% of this tabular data, which is 80% of the rows of these tables. So by doing this, once you run the line of code, you have already specified your training is perfect, and that's